Hello everyone, in this lecture we will discuss about the graphical representation of equilibrium rate or equilibrium concentration. So suppose A reactant A and B was reacted and it formed C and D, and the A and B at the start the concentration of A and B was very high, and when the A and B was combined it formed C and D. A time reached when the rate of A plus B is converted into C and D was equal to the rate of C plus D, which was converted again into A and B. So first of all we took A and B, and which were reacted to the A and B were reacted and it formed C and D. At the beginning the concentration of C and D was small and the concentration of A and B was very high. Now then when the concentration of C and D was increased, then after a certain time the concentration of C and D was become increased, and when the concentration of C and D reached to certain limit, then again C and D reacted and they formed A and B again. So at equilibrium, suppose this is the time in second arrangement, and this is the rate of A. At the start the rate of A or the concentration of A and B was very high. So rate is nothing, this rate is nothing, but it is change in the concentration with change in time. So at the start the concentration of A was very high, A and B was very high, so and the concentration of A and B was decreases with the passage of time, so the rate of A and B was decreased with the passage of time. So the rate of A and B are decreasing with the passage of time. Now similarly at the start the rate of C and D, the rate of C, change in the concentration of C with the passage of time, and similarly the rate of D, which is nothing but change in the concentration of D, change in the concentration of D with change in time. So at the start the concentration of C and D was very small and it was increased with the passage of time. So the C and D at the start was very small, then the C and D was increased. So the A and B was increased after a certain time. At the start, after a certain time, the rate of C and D, the rate of product, the rate of C and D were become equal to the rate of A and B. So this is the rate of concentration of A and B, or the rate of A and B, or the rate of forward reaction RF, and this is the rate of or the concentration of C and D, or the rate of backward reaction. So at the beginning the concentration of A and B was very high, the rate of forward reaction was very high, then the rate of forward reaction was decreased with the passage of time, and the rate of or the concentration of backward reaction was increased with the passage of time. So with the passage of time the rate of forward reaction is decreasing and the rate of reverse reaction is increases. So a time will reach in which the rate of forward reaction is equal to the rate of reverse reaction. This is the rate of forward reaction. At this point the rate of forward reaction is equal to the rate of reverse reaction. So at this point the RF, rate of forward reaction, is equal to the rate of reverse reaction, and this point is called equilibrium point or chemical equilibrium. This time is called equilibrium time, and this rate is called equilibrium rate or equilibrium point. So at equilibrium the rate of forward reaction is equal to the rate of reverse reaction, and this is the graphical representation about the rate of forward and rate of reverse reaction. Thanks.